Hello, let's continue our Sudoku adventure with a crop key adventure by Randall. So we have normal 6x6 Sudoku rules. So every row, every column, and every 2x3 box has the digits 1 to 6 exactly once each. Additionally, we have crop key pairs rules. So if you see the word pairs there, that means there's no negative constraint. It's more important to know that when you're used to there being a negative constraint in the normal crop key pencil puzzle. But either way, I'll go over what that means. So digits separated by a white dot are consecutive. So that means they have a difference of 1 is another way to put that. So if I put a 2 here, this could be a 1 or a 3, but that's it. 4 is not consecutive with 2, right? The black dots have a 1 to 2 ratio. I think the easiest way to think about that is one of the numbers is exactly double the other. So if I put a 2 here, this could be a 1 because a 2 is exactly double 1, or it could be a 4 because 4 is exactly double 2. And then what the pairs means, and then also this not all dots are given means, is I can put 2 and 4 here. There could be a black dot between them, but there isn't, and that's perfectly fine. We are not given all the black dots and all the white dots, right? This could be 2, 3. There could be a white dot between them. There's not. That's fine. We can still do 2, 3 next to each other. All right, so those are the rules. Definitely check the link in the description to try it yourself first. These are nice bite-sized puzzles, and I'm going to get started right now. All right, so it always catches my eye when you have a chain of 3 cells both separated by black dots, because it means you need to be able to multiply by 2 twice. And the only way to do that is 1, 2, 4 in a 6x6 Sudoku. When you start with 1, you're going to double to 2, and then you're going to double that to 4. If you started with 2, you would double that to 4, and then double that to 8. 8 does not exist in a 6x6. In a 9x9, you could, but in a 6x6, you cannot. So the middle digit is always 2, and it's always surrounded by 1, 4. Now, you got to be careful here. You cannot just immediately say, oh, this is 1, 2, 4, which it definitely can't be, because these two digits can be the same. And because we know the middle digit isn't a 2, I think we can actually say these two digits are the same. Let's see what would happen if we tried to make them different, right? If we wanted them to be different, then that means we have a chain, again, multiplying by 2. Because we would multiply by 2 here, and then we wouldn't divide by 2. If we divided by 2, these two would be the same digit. So we'd be multiplying by 2 again, and these would be different digits. That's the only way they're different, and that means 2 has to go in the middle, and it can't. So these two digits are the same. I'm going to mark them with green just to remember that they're the same. This one we're not sure about. Again, these two could be the same digit as each other, but they don't have to be, because this could be a 2. So we could do 1, 2, 4 here, right? Or 4, 2, 1. But let's look at this a little bit further, because we do know that these two are the same now. So what can this middle digit be? Well, it could be a 1 with 2 2s, but no, it can't be, because 2 is in this column. It can't be a 2, so it could be a 3 with 2 6s. It can't be a 4 with 2 2s. Once we pass 3, we're dividing by 2 instead of multiplying by 2. 5 is an odd number. You can't divide that by 2. And then 6 with 2 3s. So this is actually a 3-6 pair. I could mark this purple to show it's the other flavor of 3-6. And so now that this is a 3-6 pair, this black dot, just even ignoring that it's connected here, what can this actually be without 3 or 6? Well, we could be 1 multiplying to 2, multiplying by 2 to get 2, or it could be 2 multiplying by 2 to get 4, but that's it. We can't use the 3, 5, or 6. And so that always involved a 2, so there is a 2 in one of these. And so over here, we have either the 1 or the 4, the one that isn't used here, and then we have the 5, and the 5 is one of these two. We can do something similar up here. Where does 5 go in this column? 5 can't go on a black dot ever, because you can't divide it by 2, and you can't multiply it by 2. So the 5 goes here. I could have done that right at the start of the puzzle. This is a 3-6. It's what's left, and that works. If this was a 6, this has to be a 5, but you can't put a 5 on a black dot. So we do know the order. It goes 6, 3. And then this either goes up to 4, in which case this would be a 2, or it goes down to 2, in which case this is a 1 or a 4. Either way, where does 5 go in this box? It goes here. This is going to be the other 1, 4. For the box, and this is going to be 3, 6. And you can sort of see the reason for that is 1, 2, 4. 2 of them are used up here. So we don't have 2 more to use here. So this is the 3, 6. All right, I know I'm a little bit all over the place, but hopefully you're following. We need 1, 4, and 5 in this column. I'll mark it, but I don't think it's immediately useful. Okay, so what else are we going to do? If this was a 1, this would be a 2. If this was a 2, this would be a 1 or a 4. And if this was a 4, this would have to be a 2. So this is just also from 1 to 4. Are any of those restricted because of the white dot? 1 would have to be 2. 2 would have to be 1 or 3. And 4 would have to be 5 or 6. This can literally be everything except 4. I'm going to delete that because that's not helpful. So I bet there's just Sudoku that I'm missing here. Or these black dots. These black dots could be useful. So one of these could be from 1, 2, 4, but the other is going to be from 3, 6. So this one cannot be from 3, 6 because there's already one of 3, 6 in the row. So this one has to be the one that's from 1, 2, 4 and includes a 2. And then this one's 3, 6 and we know the order. So that's useful. So we know now this is the purple 3, 6 because this 3, 6 and this 3, 6 look down, forcing 3, 6 pair here. So this is also from 1, 2, and 4, but it can't be the 2. The 2 is involved here. So this is the 5. This is a 5. All right, now we're making progress. This is 1, 2, or 4. And this has to be this. This has to be the other 1, 2, 4. Sorry, we don't know which one it is. I thought we did, but we don't. Okay, so now that there's a 5 in this row, is that helpful? Oh, actually, where's the purple 3, 6 in this row? None of these are 3, 6. So this is the purple 3, 6. So it can't be a 6 because this can't be a 5. And 6 only goes with 5. So purple is 3 and green is 6. And now we can remove the colors. That makes this 6 and 3. 3 goes with 2 or 4. It does not go with 1. That doesn't actually eliminate anything from here, though. Let's see. I'm probably just missing something super obvious at this point. I do need a 6 down here, and this 6 looks down, so this is the 6. This is 1, 2, or 4. This is 1, 2, 4, or 5. So is this. Ah, it's these 2s that I marked here. They are looking left. This has to be 4. Perfect. None of those are 4. These aren't 4, so that's a 4. That's 1, that's 4. That's not a 4, so we're a 1, 2 pair. 4 can't go with 1. 4 has to go with 2. Whoops. Typing the wrong numbers left and right here, but we're just going to clean up all our red marks here, and that might actually finish the puzzle for us. That's a 5, that's 4 and 2, and our last digit's a 2. All right, 633. A little bit, I think I just didn't scan that very well, but yeah, not too bad of a time for that one. There was some interesting interactions, a lot of use of the where does 5 go? Like, you can immediately place a bunch of 5s right at the start of this puzzle if I had paid attention. So in this row, everything's on a black dot except this one here. That's where the 5 goes. Same in this box. That's the only place for 5. And then now that 5's here in this box, this is the only place for 5. A lot of that going on that I just didn't see. And then additionally, when you have 2 black dots that share a row, column, or box, one of them is going to be for 1, 2, 4 and involves a 2, and the other one's going to be 3, 6. And so that's also extremely useful to use. And so I liked this here where, you know, I'm glad that Randall included a version of a chain of 3 dots that does have a repeated digit. So you know, but giving the 2 here allowed you to immediately think, well, wait, hold on, I can't put a 2 in the middle. What does this mean? So that was really well done, Randall. I really like that. A good teaching moment. So, and then, but, oh, you don't have to repeat. This ended up 1, 2, 4, right? So cool stuff. Thank you to Randall for this puzzle, and I hope you enjoyed it as well. And if you did, why not leave a like and subscribe?